final chapter in our FFFP series about energy is photon energy, solar power derived directly from sunlight. Using photovoltaic or PV cells, more commonly known as solar panels or solar cells, we can now convert solar radiation very cleanly. The PV cell, as simple as it really is, was first developed in 1954 by Bell Labs and was initially used in space exploration. Over decades, costs dropped, efficiency rose, and solar power became commercially viable for homes, businesses, and grid-scale installations. Are solar panels completely clean energy? Well, this depends on your perspective. Here's a great example. Let us first ask the question, which leaves a greater footprint to make, a solar panel or a home computer? Hint, this is a trick question. The answer, a solar panel is indeed much dirtier to make and uses far more carbon to make than a home computer. Yet over its lifetime it will actually pay back carbon back into the carbon budget. The trick question lies in the fact that a solar panel's actual function is to offset carbon, which a computer's job is to compute at the cost of carbon. A solar panel pays back the carbon for its manufacture in about 3 years, after which it continues to actually save the world from further carbon and CO2 emissions. Added to that, a solar panel will have a life of 40 years, while a computer only 10 years. When assessing how environmentally bad a device is, you must always remember to account for its decommission from use. Fortunately, solar panels are incredibly recyclable, with 95% of their material completely reusable for manufacturing and 99% of the precious metals, including silver, recoverable. The human civilization is now in its 4th phase of energy farming. Remember our 4 Fs? We've gone from fire to fossil to fission to photon. It's important that we consider our future both as a species and as a civilization, with the subject of energy as the apex of that discussion. In particular, we need to become aware of our energy dependence and what energy actually gives us. This is important because the future of depletion is rapidly approaching, and we should be making energy choices now, not then. Nuclear fission has a foreseeable lifetime of about 100 years, when uranium ore will reach complete depletion. While we can progress on to thorium fission, it is not solving the problem of asking our descendants to protect themselves from our radioactive waste by asking them to pay for the safe containment of our radioactive waste. Our energy discussion must include a solid perspective about ourselves and of the immense amount of energy that we each now need for our lives. Is consciousness really that expensive? Well, it's not really a case of cost rather than a satiation of comfort. We've reached a point of being parked in a very comfortable spot which no one wants to back out of. We have knowledge, stimulation, temperature control, food nuance, transport communications, knowledge and entertainment, all on immediate demand. No one is backing out of such a high standard of existence, which also happens to require significant energy. We have limited energy from uranium fission, and even if we transition to thorium after depleting uranium, all we're doing is postponing Judgment Day. And if we go on with fission, it means we have a planet littered with radioactive waste, with a constant worry of contamination to water supplies and other health nightmares. The problem with fission is that we are asking our grandchildren to ask their grandchildren to pay for the safekeeping of our radioactive waste. In fact, we are asking 10,000 years of humans to maintain our radioactive waste. Additionally, we don't even know the economic situation of future generations. Perhaps there will be wars, or another form of economic collapse, rendering 1 million drums of nuclear waste to simply fend for itself. Perhaps an earthquake will rupture thousands of drums of nuclear waste, or perhaps an enemy will deliberately target a nuclear waste dump to distract and curtail a nation's resources. The fact that we will deplete the Earth's uranium reserves in a century, and that the ecology faces serious damage in mere decades from fossil energy, and that our planet can no longer support the population, are all pretty good indicators that we're now running out of energy. I'm sorry to break the news to everyone, but fission is just not sustainable. Fortunately, solar power has arrived at the ideal time. As a species, we need to reduce population, which is honestly the easiest and quickest way to reduce energy use. Unfortunately, there are a handful of powerful companies that don't want us to take up renewable energy and don't want the population to reduce. They are greedy capitalists who are intent on continuing to sell off fossil fuels for as long as they can, until they are stopped. Though rest assured that as a consumer, you hold the chain of command. And if you pursue a green future and buy solar panels, then the era of fossil fuels will quickly end. The life of a photon is an interesting phenomena of the natural universe. Unlike infrared light, visible light is extremely easy to detect, and life had no problems quickly provisioning most animals independently with light-sensitive organs called eyes. One thing we can be pretty sure about is that all animals across the universe will have eyes that see light. Photons aren't only made in suns, they are also made in everyday events, such as when you strike a flint, strike a match, or light a fire. Voila, photons are being made. The photons made in the sun are made near the core as a result of nuclear fusion. Incredibly, these photons take 200,000 to 1 million years to finally escape from the sun and travel outward, including those that land on Earth. This is because after a photon is made, it will easily deflect with other particles as it slowly percolates upward, and to eventual escape from the sun's surface. These warmth and energy that we receive from photons are only a tiny portion per square meter of the sun's energy hitting the Earth's atmosphere. There are other photon types that behave and interact differently and carry different energy levels, but they are known by their common names such as X-rays, infrared, gamma, and ultraviolet. These are all types of light, and they are all carried in the form of their own specific type of photon. Only small portions of exotic photons reach the Earth, having been blocked by the magnetosphere. The light that we receive on Earth are photons that travel as an electromagnetic wave, which the magnetosphere allows through. The key words to how different photons move are waves and fields. Visible sunlight are photons that travel using electromagnetic waves, while higher energy photons travel by using electromagnetic fields that use charged particles. Electromagnetic waves are not affected by the magnetosphere, while electromagnetic fields are affected. Now, if you've woken up, you'll understand that photon energy is clearly the key to the future. With photovoltaic cells, we can now collect a larger sample of the sun's energy over a larger surface area and then collect the total sum of energy for a useful purpose, such as for a refrigerator, a microwave, or whatever. Solar panels are a great technological development, but are not the final development. We can also use the sun directly for solar hot water systems, and if more homes did this, it would considerably lessen the carbon footprint on the planet. Over the past 40 years, there has been documented first contact meetings with tribes in New Guinea, South America, and in Manhattan, New York. Just kidding about the last one. In all first contact situations, tribes have later commented when asked that the most loved improvement in their lives was soap and hot water. Tribal members repeatedly declare that even above clothing, food and medicine, that the one thing they could never go without again is the luxury of bathing or showering in hot water with soap. They say that the experience and the feeling of cleanliness after is the greatest of comforts from the modern world. What this says is the same for all modern human beings, and what is already an established fact with energy specialists. The fact is that hot water consumes more power than any other single item the world over, including even cars. Wow. Apparently, we all like to feel clean. The bulk of your home energy will probably be used for hot water. The point here is that solar hot water systems that heat water directly from the sun significantly reduce the cost of hot water. And no, you don't have to heat water completely from the sun, but just by having a solar water preheating system somewhere on your roof, you will significantly reduce the cost of the hot water, perhaps by 90%. So we don't have to use solar panels for everything. Hot water, our primary energy use, can be offset simply by a black painted holding tank on your roof, and your energy use will come down. If we begin to build our homes, streets and entire suburbs with correct solar orientation, we will then be able to minimize heat loss in winter and maximize heat gain in winter. Indeed, with modern technology, we have the world at our fingers with a new energy era. And a main takeaway here is that we are no longer talking about just one technology to solve all. We're also talking about smart thinking and design, to flow and cooperate with nature more, to minimize energy loss and maximize energy gain and time energy events. We're talking about computers, artificial intelligence and knowledge to bring us through for the long term. Wind is also a big factor in drawing energy, and it is now a fully developed technology. The only drawback of wind is that it is expensive to maintain owing to moving parts. Energy conservation is also a new process, but is an ideology rather than a technology. It can significantly reduce power consumption in a home. For example, double-glazed windows can be hugely expensive, but at a fraction of the cost, a homeowner can add each window with 6mm acrylic sheet. 6mm acrylic sheet significantly reduces heat transfer. Solar panels typically install in a 6.6 kilowatt-hour configuration on most home roofs, though they can be bigger if the roof allows. 6.6 kilowatt-hours will rarely generate enough power for 2 people in a home. However, an 8 kilowatt system can pull it in. So if you cannot get more than 6.6 kilowatt-hours on your roof, you can spend money on DIY acrylic glazing of windows, roof insulation, and buying better heating appliances. Another trick is, if you have ample roof area for a 10 or 13 kilowatt system, fill it all with solar panels rather than investing in a hot water heat pump. Water heat pumps are very expensive, with low warranty, and don't add up to hardly save money with ownership cost. And if it breaks down just out of warranty, you really have a dilemma. Rather, spend the money instead on more solar panels and just a normal element, tank, hot water system. The sun, our oldest and most reliable energy source, is now central to our clean energy future. Photon energy is abundant, renewable and decentralized. It empowers individuals, reduces dependence on geopolitics, and aligns human civilization with planetary rhythms. Solar, alongside wind and storage technologies, represents the clearest path to sustainable progress. Unlike prior stages, photon energy offers a route to harmony between humans, technology and the environment. It's not merely another form of energy, it is a philosophy of renewal, equity and long-term resilience. Our long-term energy solution is here, and it's not a single solution. It is solar panels, solar hot water heating and smart thinking. We can no longer afford to be flippant with energy. Crunch time is here, and we really need to think more about how, when, if we use energy. We need to vote no to fission and to buy solar as soon as possible.